So, as in the previous presentation, right, for digestion, we had gotten through talking about basically kind of the upper portion of the GI tract, really upper and lower portions of the GI tract, right, beginning in the mouth, then from in the oral cavity, and then going down through the esophagus, eventually leading into the stomach, and then all the intestines. We'd gotten through all of that. Now, where we kind of left off, or where we kind of got to, was talking about all of the additional organs, all the additional glands which make contributions to digestion. Right? There was the liver, the gallbladder, the pancreas. Right? When we got to the point of the duodenum, right? There's a huge amount of enzymes. There's something called bile. There's a huge number of digestive secretions which are dumped into the duodenum. Right? The vast majority of digestion and absorption occurs in the duodenum. Right? I mean, as much as 80+%. And part of the reason why that is from the pancreas. Right? The pancreas is filled with pancreatic acini. Right, we'll look at those in a second, and also on the endocrine PowerPoint. There's also quite a few images of the pancreatic acini along with the pancreatic islets. Right, in the endocrine section, the pancreatic islets we paid attention to because of the production of insulin, glucagon, somatostatin, pancreatic polypeptide. Here, in this digestive system, right, we're going to pay attention to the pancreatic acini because that's where the actual digestion or the digestive enzymes are produced. Right. Along with that, right, way up here in the gallbladder, right, the gallbladder is going to store bile. Right now, the gallbladder does not produce the bile. Right. The gallbladder, right, stores the bile, which is produced within the liver. So the liver produces the bile. Right. Then there are these ducts. Right. The common hepatic duct. Then we see the cystic duct. Right. This feeds into the gallbladder. Right. Now, let's say when it's time for bile secretion to occur. Right, because of, for instance, gastrin or CCK or any number of different any number of the duodenal hormones which are released, bile is going to eventually travel down into the common bile duct. Right down through here. Now the common bile duct is going to unite with this structure here. This is the pancreatic duct. Pancreatic duct. Okay. Where they combine, you see this where they have the hepatopancreatic ampulla, or it's something called the ampulla of Vater. That's simply where both the bile and the pancreas, or the digestive secretions like the amylase, the trypsin, the lipase, that's where it dumps into the duodenum, is right here. So it's a little kind of closer of a view, a little closer up. Again, same thing. We see this opening into the actual duodenum itself. Right, here's the lining of the duodenum. We see all in through here. Here's the common bile duct. Right, this is where the bile comes down from the gallbladder. Remember, right, just because somebody may excuse me, just because somebody may have or may have had their gallbladder removed does not mean that they don't produce bile. They absolutely do. Right? Remember, the liver produces the bile. The problem is that without a gallbladder, that bile is not able to concentrate. Right? So we can't amplify the bile secretion if we eat some sort of high-fat diet. Right? Bile is also related to the elimination of cholesterol. Right? So people originally thought, if we eliminate the gallbladder, that affects, cholesterol, the elimination of cholesterol, and that sort of thing. However, it's kind of irrelevant in the standpoint that the bile is produced in the liver, right? And people can't have liver, right? You can't have your liver, chopped out, right? Even as important as the liver is, even the fact that, as long as there's 25-ish% of the liver left undamaged, it can repair itself. It's still an immensely important organ. So, anyways, this image here, again, this is just kind of an up close and personal view of the hepatopancreatic ampulla. And this here, right, in case you kind of forgot, this is pretty much just kind of a tract of where these, or how the secretions get from the respective organ into the duodenum. Right, you can see, right, the right and left pancreatic duct, the hepatic duct, right, those are the ducts within the liver, right, you see hepatic, think liver, right, that dumps into the common hepatic duct. Again, that's from the liver itself. Now that feeds, again, we can follow this now, we can see eventually that will lead into the common bile duct, along with the pancreatic duct from the pancreas. Again, the pancreatic duct, the different digestive enzymes, amylase, trypsin, lipase, those are going to dump into the pancreatic duct as they combine, right, just like we saw in this image here, as the common bile duct, as the pancreatic duct combine, that gives rise to the hepatopancreatic ampulla. And just because you guys know, much bigger and gross, cadaveric images, this is what we see. Right now, this image, right, don't get confused, a number of things that had to be removed, right? We see the spleen here, the stomach was in this region here. It is no longer, right? It had to be removed in order to see the pancreas, right? A large portion of the liver was shaved off, right? So it had to be in order to expose the entirety of the liver. The entirety of the pancreas. Running through here, you can see, right, here's the duodenum. This is that first part of the small intestine. And right here, right, this is the this is the pancreatic duct here. Here's the common bile duct, and this short little, I don't know, in this image it's a half of an inch in length. This is the hepatopancreatic duct right here. Again, same thing, right? Just kind of up close and personal of the. So just another cadaveric image, right, of the pancreas here. Now here's where we're going to start to get into the liver and how the liver produces the different number of secretions, right, or the number of, for instance, the bile. The other thing about the liver, right, the liver is the kind of ultimate adjuster of the composition of the blood, right? The food that we eat, right, anything that we put inside of our mouth, once it's absorbed through the intestinal wall, right, the vast majority of what we consume, carbohydrates, right, proteins, small, medium chain fatty acids, even some large chain fatty acids, right? All of those are going to cross the intestinal wall and enter into the bloodstream, right? Specifically the mesenteric, right? Depending on where they are, eventually, right, they're going to lead into something called the hepatic portal vein. The hepatic portal vein feeds or leads into the liver. Now, in these regions through here, in the hepatic sinusoids, this is actually where we have the combination of both arterial blood as well as venous blood combined, right? So blood from the hepatic artery as well as blood from the hepatic portal vein are going to combine in these hepatic sinusoids. Right? When that happens, all these different hepatocytes, right, all these different cells out and through here, these have the opportunity to adjust the composition of the blood. Right, if we ate a super high carbohydrate laden meal and we have an abundance of glucose which was absorbed, our liver has the ability to store large amounts of that glucose if they're not needed. Right, our liver also has the ability to convert fatty acids into triglycerides, and then those triglycerides, in order to leave the liver, have to be converted into VLDLs, or very low density lipoproteins. Right? Triglycerides in and of themselves do not have the capability to leave the liver. That's why, again, if you've ever heard of like fatty liver disease, right, whether it's alcoholic fatty liver disease or non-alcoholic fatty liver disease, what happens is your your liver is not designed to store fat. Fat is designed to store fat, right? Adipose tissue is designed to store fat. So the problem with, again, somebody who develops fatty liver disease, for instance, is their liver has an inability of that triglyceride or of that fat to actually leave the liver. Right, and part of the reason why there's a few different mechanisms as to why, but there's reasons as to why, or that the liver struggles to convert that triglyceride or that fat into a cholesterol. Right, the triglyceride in and of itself is incapable of crossing through the wall, the hepatocyte, through the wall, and actually exiting the liver. Right, as long as it's able to convert into a VLDL, right, into that very low density lipoprotein or cholesterol, it can leave the liver. Then once it leaves the liver, it can then travel to the adipose tissue, wherever that particular molecule of fat is going to be stored. Right, because it can't be stored in the liver, or it's not supposed to be stored in the liver. And if it does, that's where we begin to develop, again, fatty liver disease. Just kind of another image, just a little more blown up. Again, in through here, these sinusoids, here, right? All these sinusoids, when you look at them, right, all these different sinusoids all lead to this one vein. Right? Think about it. There's kind of a branch of the hepatic portal vein comes up, and it kind of just flows. There's all these small little tributaries, which all lead into the central vein, and it kind of makes sense, great, because that's what I had mentioned. The liver is like the ultimate adjuster of the blood. If there's too high glucose levels, the liver can store some of the glucose. If it's too high fatty acid levels, right, the liver can make the conversion of triglycerides, and eventually triglycerides to cholesterol. Cholesterol is then vacated and goes and travels to the adipose tissue, wherever it happens to be, back of your arm, your butt, stomach, wherever it is. Right. The liver can also break down medications. Right. For instance, that's why certain medications you have to take are allowed to take so often. Right. Some of them have to do with the renal clearance rate or how quickly the liver breaks them down. Other ones have to do with how effective the liver is at breaking them down and metabolizing them. So, again, it's responsibility of the liver as well as the kidney a little bit too. But the fact that there's all these kind of small tributaries or these sinusoids which go from the hepatic portal vein and stem through all these hepatocytes, that gives the hepatocytes the opportunity to be able to, again, metabolize the different molecules that are within the blood. Because, again, that blood is within the sinusoids themselves. Again, another just up close and personal. Right. Here you can see, as I mentioned, right, within the sinusoids, that's where the arterial and the venous blood mix. Right, because here we see right here is the hepatic artery. It comes up. We see all these branches, branch coming off here, branch coming off here, branch coming off here. And we can see that blood from the hepatic artery dumping into this sinusoid, along with this blood from the hepatic portal vein. That then dumps into the central vein. Eventually, the central vein feeds into the hepatic veins, and the hepatic veins feed into the inferior vena cava. Inferior vena cava goes back to the heart and then dispersed throughout the body. So just a histologic image we see here, right, under a scope, what we're looking at. This is that central vein, right here. Again, all these sinusoids feeding back into that central vein right here. Right here is the central vein. Right. So all these little kind of white tributaries. Now, granted, we can't really see where it dumps into the central vein terribly well. You can see it right through here a little bit. Right, but there would be all these kind of whitish little tributaries, right, in through here. And here's a good one. All of them would be feeding into the central vein. This here, again, this we just covered, right, as far as the oxygenated and the venous blood, right, as far as the order, right, dumping into the sinusoids, right, these things here, dumping into the sinusoids, from there into the central veins. The central veins all combine and feed into the hepatic veins. Then the hepatic veins give rise, or not give rise, but they then feed into the inferior vena cava.